Welcome back, friends. I've made some progress. Now our player sends its coordinates to the server when running, and the server now stores them in the DynamoDB, so we know where exactly our player is. Almost the whole last week I was fighting with the WebSocket API gateways. It just didn't connect me. The Unity client code was working, but as soon as I opened it, I got a request back from the web server WebSocket API saying that it disconnected us. As a result, I had to create a new WebSocket API gateway on the AWS UI to make it work first. Even that exercise took me a while, 2 days to be precise. Then I had to completely refactor the code that was provisioned in the WebSocket API gateway. The problem was in the way how WebSocket API creates its integration with the backend services. In our case, it's a Lambda function. Initially, I did everything in a similar way with how HTTP API gateway is usually set up, but that didn't work. So I had to completely redo it. For now, I ended up with three endpoints in the player WebSocket API: connect, disconnect, and coordinates. The last one is responsible for obtaining the player coordinates and storing them in the DynamoDB. In terms of the code now, I've done some refactoring and I had some thoughts of the proper data and the class structures. We can't just dump scripts in the root folder and assign them randomly to game object in Unity UI. This will become unmanageable when we have lots of scripts. So I split the code into many isolated by design C# namespaces. Each of them will be responsible for some particular parts of the game. Many of them are empty now, but we will fill them in with scripts in the future. You can see the structure now on the screen in Unity. Here is what it looks like in Rider. Empty folders are not visible, so we can concentrate on what we already have. We will keep the main scripts in the core singleton namespace. Those will be the unique instances of our objects. Here is an example of how we will be dealing with the player script. This is the root script for all players components. In the Unity editor, we will assign only this script to the player, and it will do the rest for us. As we will have all the logic split by different types, where each of them will be responsible for its own stuff, like moving on the map, object interaction, sending coordinates to the server, receiving updates from the server, and so on. The main script will be responsible for coordinating all parts of that whole player code. It will create and remove components on load and as requested and required by the game logic. It will make sure those components will be able to share some required data between them, but internal details are not visible globally. We don't want any other scripts to mess with the internal implementation. The same will apply to other type of objects like monsters and items on the map. Now let's talk about the player movement and how we send this info to the server. In our players class, there are two move components that are dealing with the player movements. One of them is the game logic. This component, particular, is responsible for dealing with the visual parts of the game. It checks if we clicked on the map and starts moving the player to that direction while updating its coordinates on every frame. Also, the important part here is that it sets the global flag that states if the player is running and what the current coordinates are. Another component is the network movement. This component deals with sending the current coordinates to the server. It checks the flag if the player is running, the same flag as we set in the previous component. And if it sees that the player is running, it starts sending the current coordinates to the server every 500 milliseconds. And in the end of the movement, because we don't want to lose any latest frames if it doesn't fit within a 500 milliseconds. It takes the coordinates from the same place where the first component saved them to. For now, for debugging purposes, I output the outgoing message to the console. You can see how it sends the information to the server. In the message, we have the field called action. This field is the key to how the server understands which endpoint to use in our API. It acts as a normal endpoint for plain HTTP API. As WebSocket API doesn't have endpoints as such, we have to separate it by sending this action. This is, of course, all configurable in the API itself. I just chose the word action to separate it, but it's totally up to the person who sets up the API. So as you can see, now we have two components and they don't depend on each other. They just do their logic separate from each other. They know nothing about each other. That's how we separate the logic. We don't want everything to be in the same class. There are some limitations to what I've done so far. As you can see, we store the information on the server, but we don't read this information from the server when the game loads. Hence, our player always starts from the game's default coordinates, and as it starts moving, this will override any existing coordinates on the server. Also, there is no login process currently. As soon as the game loads, it connects to the server without any checks. Then it just assumes in the backend code that the coordinates are sent for the player with ID 1. I created this player manually in the database. To make it a bit more real, we have to either create a registration flow or at least give some option which players you want to log in as. Without it, we won't be able to test the players' interaction with each other. And we will start doing this in the next video. And the last, wanted to mention the timings on the server. The code works relatively quickly. The first request to write to the DynamoDB takes around 60 milliseconds, which is not bad at all. And the subsequent writing takes only 6 to 7 milliseconds, which is great, as we'll have more available time for our network delays and other parts of the whole WebSocket call chain. Connect and disconnect calls from the client are processed within a couple of milliseconds only, which is also great. That's it for now, guys. See you in the next video.